Hi everyone. So today we'll be discussing on lab 3. Um, Let me bring in the problem statement. Yeah, so this is the problem statement. We have this topology, right? We have R1, R2, R3, and R4, right? Four routers. Um, R1 is in AS65001, right? 8 R2 is in 65002. R3 is in 65003 and R4 is in 65004, right? So R1 and R4, we have a couple of loopbacks, right, which are advertised, right? In R1 we have these loopbacks, right, and in R4 we have this loopback. And R2 and R3, okay, are you can assume that R1 and R4, right, are a network, right? Uh, a partner network, okay, which should have reachability to each other, right? And for redundancy purpose, they have connected to two different ISP. We can assume R1 and R2, R1, R2 and R3 as ISPs, okay? So R2 is in primary ISP and R3 is a backup ISP, okay? So this is the interfaces and IP, right? ISP A is designated the primary path for all traffic, and ISP B is the backup path used only if ISP A is unavailable, right? So this is dual homed, right? Dual homed. So our problem statement is any traffic which is going from R1 to R4, right, should traverse through R2. And also the traffic coming back from R4 to R1 should traverse via R2. Okay. R3 should only be used when R2 is unavailable, right? So R2 is a primary ISP and R3 is a backup ISP. Okay. Let's log in into the device. Let's log in into R1 first and see how the communication is happening. Okay. So I am trace routing to one of the IPs on R4, right? With R1's IP, R1 loopback as a source. Okay. And what do we see here is the route which is being used is 10.13.0.2, right? If you see 10.13.0.2, right, this is on the ISP B, right? So the path which should be used should be 10.12, right? But 10.13 is being used. Okay. So definitely there is some misconfiguration, right? Or there is some problem which is causing the traffic. Our intended path was from R1, R2, R4, and from back from R4, R2 to R1. But somehow the path is going from R1 to R3 to R4, right? So um, let's see on R1. Okay, this was bash. So let me log in into, right? Yeah. So if I log in into this router R1, right? And let me check on route 1. What is the route towards 10.4. 0.0, 10.4.0.0 is our R4's loopback, right? And we can see that it is the best route is towards is from 10.13.0.2, right? Which is on R3. Okay. This does not seem correct, right? So let's see, show IP route. Okay. From show IP route, I can see that 10.13 and 10.12 both are directly connected here, right? So um, from the routing perspective, right, it's not like we are not getting any one of the routes. Okay. So let's see the configs first. Okay. So let me check the running config. Okay. In running config, right, I can check that there is an AS path append configured. Okay. There is a metric configured. Okay. And then there is a local preference configured, right? So this local preference if you see permit set LP high, permit 10, right? Um, this local preference is assigned on which set LP high is towards 10.13.0.2. Okay, so our higher local preference is towards 10.13.0.2, right? And on 10.12.0.2, we don't have configured any local preference. Okay, so local preference is configured 200. Okay, by default local preference is 100. Okay, so our 10.13.0.2 will have a higher local preference and 10.12.0.2 will have a lower local preference, right? So we know that in BGP path selection, higher local preference always wins, right? So therefore, path towards 10.13.0.2 will be selected rather than path from 10.12.0.2. Okay. So before going further, okay, let me bring up the uh, a little bit on best path selection. How is best path selected in BGP? Uh, so these are a couple of basic things on BGP. Okay, we know that BGP is an exterior gateway protocol, right? It uses the TCP port 179, and it is a path vector. It is a basically a path vector routing, right? There can be two type of BGP sessions, eBGP and iBGP. iBGP basically within the same AS, eBGP between two different autonomous systems, right? These are the different type of BGP messages, right? We have open, update, keep alive, notification, and route refresh, right? Talking about these are a couple of things, uh, terminologies which is specific to BGP, right? Now let's see on the best path selection, right? So we have to think in this way that whichever step is the first, right? Whichever step matches, right? After that, the selection process does not move ahead. Okay, so if it the decision is made at step two, so then step three is not taken into action. So this is like a brake mechanism. Once one is done, if there is no decision made based on step one, then we go to step two. If the decision is made based on step two, right, then we break it there and there itself. Okay, we don't go to step three or four. Okay. Now, first step is the wait. Okay, and this wait is somewhat Cisco proprietary. Okay, and it is local to router. So highest wait always wins. Okay. Now, second is local preference, right? Which we were seeing just now, right? Local preference is also higher local preference always wins. Okay, and local preference is shared within the same AS only. Okay, if it is not transmitted on the AS boundary after it is only in the same AS. Okay, if take effects in the same AS. Okay, now here, this is the rule which happened on our use case right now, correct? Where the local preference, higher local preference win, and the path, the traffic was routed from R3, right? The path towards R3 won, right? Next is if it does not satisfy any condition here, so then it moves to locally originated. Okay, local routes are preferred. Then it moves to AS path, right? Shortest path wins. Then we have origin code. Okay, IGP is preferred over EGP. EGP is preferred over incomplete origin code. Okay. Then comes MED, multi-exit discriminator, right? In MED, the lowest MED will win. Okay. If from these six we are not able to take decision, then we go to the next steps. Okay. Seventh is eBGP is preferred over iBGP. Okay. If even after this it is not resolved, the lowest IGP metric to the next hop is preferred. After that, oldest eBGP route is preferred. After that, lowest router ID is preferred. After that, shortest cluster list is preferred. After that, lowest neighbor IP is preferred. Okay. So this is these are all the path selection mechanism, right? And it goes step by step, right? In our lab, will most all our problems will have solutions in these first six only. Okay, so we need to remember all these six when we are doing our lab today. Okay, so first wait, then local preference, then locally originated, AS path, origin, and med. Okay, Now let's go back to our lab here, right? And now we can see, if we take our understanding from that PPT and put it here, right? We can easily see that this route map is applied towards 10.13.0.2, right? And it has a higher local preference. The default is 100, right? Therefore, it is this path is preferred, right? So uh, this is what we can see directly after after seeing the PPT. We can understand it very clearly, right? So we will fix it, right? So um, right. So let's fix it. Um, right. It's going to offer BGP 65001 address family, right? And we want that this should be applied not on 10.13.0.2, right? It should be applied on 10.12.0. Right? And on 10.13.0.2 we will do it no never. Okay, otherwise if we will apply it on both, then the metric will be the local preference will be same. Okay, so based on that it won't be able to identify, or it won't be able to conclude where to route the traffic, right? So our whole purpose will be lost. Okay, so here as of now I will remove it from the R3 side, okay, and keep it only on R2 side. Okay, now let's see. Let me exit. Okay, now let's see uh, this route. Correct. Now we are seeing it that it is going from 10.12.0.2, right? Uh, let's see it from BGP's perspective. We are seeing that there are two paths, right? One is 10.13.0.2, one is 10.12.0.2, right? But this is best because of the local preference, right? So we can see it clearly from our lab that this output that the other path is preferred because of the local preference, right? So that local preference, higher local preference wins here. Okay. Now, um, let's see the trace route now. Okay. Let's see the trace route if it's working properly now. Okay. So from this side, 10.12.0.2 and 10.4.0.1, right? From R1 side, it looks fine, right? But from, let's see from, now let's see from R4 side. Okay. Yes, 10.34.0.1, right? If we see 10.34.0.1, this is the path 10.34.0.1, right? So it is from R1 towards R4. I'm seeing the path correct, right? Because of the local preference, but from the traffic which is going from R4 towards R1, right? It is still preferring the R3, right? So one thing to remember is when we were from R1's perspective, when we were taking care that we have to move traffic towards R2 and not towards R3, basically it is a local decision, right? Which is the decision has to be taken in our own autonomous system, right? But when we want the traffic from towards R1, right? But when it is coming from R4 towards R1, it should prefer route via R2, not via R3, right? This decision is not taken within the same AS. Okay, this is taken across the AS boundary. Okay, this is an important understanding, right? So here we will not be able to use our local preference, right? Because local preference, as I mentioned, is only in the boundary of our AS, right? Beyond that AS, that local preference is of no value, right? So therefore, the traffic which is coming back from R4, it is taking still the path from R3. Okay, but we have some tools which we can use to affect that path as well. Okay, so let's log in back in R1. Okay, now let's see the configuration back again. Okay, yes. So what configuration do we see, right? We see that um, we have some metric assigned, right? We have this metric of 10 and this metric of 100, right? And this metric is for prefix net 1, right? Prefix net 1 is only matching 10.1.1.0, right? And we are setting a lower metric here, right? So the metric already is lower, right? If you see from this perspective, correct? The metric towards ISP A is already lower, right? So if you go back on our PPT, we know that med is the lowest, med wins, right? So the med value is correct, right? For at least for prefix net 1, right? But let's go on R4, right? Now if we see on R4, right? Um, One thing to understand, right, from BGP med comparison rule, right, is that the med will only be compared, right, when both the paths, right, are received from the same neighboring AS, right? If the paths are being received from different neighboring autonomous system, the med is not compared. Okay. But since R2 is in 65002 autonomous system and R3 is in a different autonomous system, right? They are using different neighboring AS, right? Therefore, R4 will skip the completely the med comparison, okay, and it will go to the next path, right? Uh, so if we, but there is a configuration which we can do, right? Always, which will force our router to always do the med comparison, even if it is coming from a different AS. Okay, so we can do that. Okay, BGP always compare med. Okay, this configuration. But if we think through, right, then we will understand that let's see the route. Okay, then we will 10.1.1.0/24, right? Sorry, let me exit from here, right? Now what I'm saying is the route from 10.34 is still preferred. Okay, not because of any of our BGP best path selection, but just because it is an older path. Okay, so that med is not taking effect here, right? And the med is not taking effect here because med is a non-transitive BGP path attribute. Okay, so when that med value goes from R1 to R2 or R3, okay, it will reach to R2 and R3, okay, but from R2 and R3, right, it will not go ahead to R4, right? It will be it is non-transitive, as in it cannot pass to different autonomous system. Okay, once it goes from one autonomous system to another autonomous system, it will be there till that autonomous system only. It will not be passed on to the next autonomous system. Okay, since we don't have any med value coming towards R4, right? It is of from R4's perspective, right? These both paths are equal, right? When they are equal, so it falls back to the older path, which was one of our tiebreakers, right? Later. So what would be the better alternative, right? So one of the better alternatives to fix this, right, would be AS path prepend, right? Now, if you go back to AS path prepend, right, we know that shortest AS path will always win, right? So this AS path is basically the how many A's have our route traversed. Okay. So basically, if you see here, when it is coming to R4, right, we know that it was originated from 65001 and this route is coming from 65003, right? So this is our AS path. Okay. And this is our another route from for another AS path, right? This is for another route 65002. It is coming from 65002, right? So we can forcefully increase this AS path length. Okay. And if we increase the AS path length toward 10 dot toward R3, basically this route's AS path length we will increase somehow, right? Then this route will not be preferred, right? Because then ultimately this will only be this will be become a smaller AS path, right? Let's see how we can do this on R1. Okay, so this thing has to be done from R1. Okay, we don't have to make any configuration change on R4. Okay, because as I mentioned, uh, it is R1's the R1 is the where a primary and backup kind of configuration is there, right? So it is R1's responsibility to make the kind of change that is propagated towards the entire network, right? Later network, and it can transfer the traffic in such a manner that it reaches R1 properly, right, to the path it is intended, right? It is not intended that we make configuration changes on R4. Okay. So even this change which we made, BGP always compare made, right? This is just for illustration, right? But ideally, I won't have in general networking aspect, right? Many time I won't have access to R4, right? Because this is not my autonomous system, right? I will have access to only my autonomous system and only configuration change, which whatever I can do is only on my autonomous system, right? So I cannot do anything on R4, right? Whatever I have to do, I have to do on R1. Okay. So let's see the configuration again, right? This is what we see, right? Uh, yeah. So let's configure our route map, right? We already have the route map. Okay. But it is just that it is not working properly, right? I will go in that route map. Okay. And I will set. So if we see this route map, right? This route map is actually matching the prefix net 1, right? Prefix net 1. And this is applied towards 1.10.13, which is basically our R3, right? And we want this configuration, this AS path configuration to actually be applied on R3, right? Means towards R3, correct? So what I'll do is I will prepend my AS path, right? With uh, this, okay? So now what will happen is when the route will go to R4, right, from R3, right? This is only applied towards R3, right? Not applied toward R2. So nothing will happen towards R2. When that route goes from R1, only one time 65001 will be applied. Okay. But here, since I'm forcing the router, right, to append 65001, right, it will append it three times. Okay. So rather than one, we will have three, right? So through this mechanism, our path, which is the same path, right, which is going from R3 will become longer, right? Virtually longer. Okay. So now whatever is there, this from this path, R2 will become shorter, right, due to AS path length, and the path which is coming from R2 will become the winner, right, because of the shortest AS path that rule. Okay. But we are seeing one AS path also configured, right, uh, towards path A, right? This is for prefix network A. This is prefix net A is only matching this, right? But there is also prefix net 2, which is matching this, right? And this is applied towards 65001, and this is wrong, right? Because what we want is we don't want the path from A to look larger, right? We want the path from B to look larger. Okay, so we can configure, we can change that as well. Okay, so what we can do is we can take this route map, right? And we can do no set AS path prepend, right? So whatever AS path prepend is being turned towards ISPA will be removed, right? And what we can do is we can go and apply that same AS path to ISP B side, right? And this will be similar to what is already there, right? This is what we want to do towards ISP B. Nothing, the path should not be longer from which when it is coming from R2. Okay, the path should be longer when it is coming from R3. Okay. Now what will happen is ISP B will have a larger AS path, right? So it will not be preferred over ISP A. ISP A should always be preferred, right? From both the sides now. It should be preferred, right? So let's go and check on R4 now. What happens? Exit, exit. Okay. We logged in into show IP BGP 10.1.2.0 right? What we are seeing is still the best path is the first path received with the older path. Okay, why we are not seeing anyways two paths here. Okay, and in 10.1.1.0 also, okay, I am seeing the path, only the path which is coming from 65002, right? This is correct. I am receiving the path from 65002, therefore all the trace route and everything will show it correctly. Okay, because we wanted the traffic to move from R2, right? But this is wrong, right? We wanted that the best path selection should be done based on AS path, right? Where when the traffic is coming from R4 towards R1, the routing, the best path selection should be done based on AS path, right? But what we see on R4 is that for both the routes, we are even not seeing the any route advertising coming from R3. Okay, so there is definitely something wrong. Okay. Now let's check on R3 once why this is showing this kind of thing. Now let me see show IPBGP 10.1.2.0/24, right? I am seeing that 10.13 we are seeing a path prepend happening here, right? But one thing we are which I can look is see is on R3 this route, right, is having an ACE path of 65004. Okay, so R3 is somehow receiving this route, right, which is coming from 65004, but it should not be happen. It should not happen like that, right? The route, all these routes are originating right from 65001. Okay, so there is definitely some loop which is happening. Okay, so to show you in the diagram, right, what should not happen is whenever we are getting any whenever we are sharing any routes from R1 to R2, right, and that going to R4, right, it should not be, that route should not be coming back from R4 to R3, right, and back to R1. It should not happen like that. Okay, this kind of what will happen then is R4 will become our transit. Okay, transit as in even if the traffic is supposed to destined for ISP B, say from R1, we want to send the traffic to ISP B, not to R4, right? It can happen that in some situation that the traffic could flow from R1 to R2 to R4 to R3. That should not happen. Okay. So in any case, R4 should not become a transit path for the traffic towards R2 or R3 or for say for any other customer. Okay. Only the traffic which is destined for R4 should come to R4. Okay, so what we can do is we can apply one some kind of filtering on R4. Okay, I will create two prefix lists. Okay, two prefix list for these routes which are coming from R1. Okay, 10.1.1 and 10.1.2. Okay, okay. What I'm doing is any route which is coming from R1, right, should not be sent to R2. All the other traffic can be sent, right? Same, all the traffic towards R3, I am applying the same thing. Okay, it should not go towards R3 also. And uh, same thing. I am allowing everything else, all the other prefixes, but just the prefixes which are coming from R1 should not go towards R2 or R3. Okay. Now let me apply it on the neighbors. Okay. So this is towards R2 and this is towards R3. Now let's see. Uh, 1.2.0 slash right. Now we can see it correctly, right? Now R4 has two routes, right? From R3 and R2, right? When it is coming from R3, right, we have 165001 is already attached, right? And apart from that, three more 65001, these numbers are attached, right, to the AS path list, right? And at last 65003 from where it is coming, right? So if these three numbers were not added, right, then this path with 65003, 65001, and this 65002, 65001 would have been same, right? Then the best path, next best path, whatever decision would have been taken, right? But we have forcefully added these three numbers, right, in this list. Therefore, this path appears virtually longer. Okay, and therefore this path is selected, right? It is clearly mentioned that this is due to AS path selection, right? Now let's look the same for one also. If it is happening for one also, right? This is happening for one also. Same kind of situation we can see, right? 65001, and this path has become shorter. Therefore, this path has been selected, right? Now let's see the traffic which is coming back, going back from R4, right? Is it taking the path which we wanted it to take, right? Uh, let's run the trace route on R4. What are we seeing? Right. We are seeing that on 10.224, right? It is selecting the interface which is towards R2, right? Now let's see finally after we have made some configurations, lot of configuration changes, right? So let's see if R1 is also behaving as we wanted it to behave, right? On for both the prefixes, right? Uh, Correct. Now it is taking 1, 2, right? 1, 2 that is towards R2. And this is also taking the same path, right? The R2 path. So if it is clearly showing that the traffic which is going to and fro from R1 and R4 are taking the same R2 path, right? So what we uh, discussed today, right, were three important things, right? One was local preference, right? One was AS path length, and one was med. Okay. In local preference, highest local preference will win, but it is shared within only the same AS. Second, med. Med higher med, the lower med is always preferred. Okay, but it is non-transitive, so it will not be passed to the only the med value will only be in the between the neighboring AS, right? It will not be passed further. Okay. Now AS, when we are having the med, right? So if the routes are coming from two different med, right, then they are not take the med comparison will not happen, but there are ways on router to force that med comparison to happen. Okay. Now next is AS path length, right? AS path length, shorter AS path will always win, right? And you will always have to do some kind of manipulation on AS path. If you are having two routes, right, which is following the same path and going to your destination path, right? And you want that the traffic from that destination towards you should come via particular path, right? Then you have to virtually increase the AS path length. And we saw one more thing, that even if all of these are working properly, right, it can happen in some situation that our destination can actually become a transit, okay, and it can start advertising routes back to our ISPs, okay. So to prevent that from happening, we can apply this kind of uh, uh, path route filtering, right? So that those routes are not advertised back to the ISPs, right, or back towards us. But just before closing, right, applying this kind of prefixes, right, prefix filtering is very crude way of doing this. Okay, the better alternative would have been that we could have matched it based on the some kind of AS path filtering. Okay, and we could have configured the rule in such a manner that if the that uh, route is not originating from R4, then we don't have to advertise it further, right? Because if the route is originating from R4, right, then it will have its R4 AS, right, which said both of them does not have, right? So these routes will not be advertised further, right? But the routes which are actually originating from R4 will be advertised towards R2, R3, and further towards R1, right? But here we have kept it very simple, right? But this simple approach will not work when the number of prefixes will increase, right? Because then you will have to go again and change all this prefix list, right? And this prefix list, uh, uh, the number of prefix lists will increase, right? So we cannot continue adding one prefix lists. That will be that is not a scalable solution, right? The more scalable solution could be some kind of ACE path filtering, okay? But here we had only two prefixes, so for a easier approach, I used this kind of filtering, okay? Thanks for watching this video.